we have two presenters. We have Nellie Gustafson, and we have UC. I have known them from inside Microsoft. His last name Jayachandran. So he goes by UC, and they're going to be talking about the SQL Server R services technology. SQL Server R services technology. So I will turn now the control of the presentation to Nellie, and she will start inside her slide deck.
Yes, thank you, Mark. So as Mark said, we're going to introduce SQL Server R services, and I will hand over to UC to begin. So my name is Nellie Gustafson, and I'm a program manager here in the SQL Server product team. And this talk is going to be the first of hopefully several talks, and it's going to be an introduction to our services.
Yeah, my name is Umachandar. I go by UC. I'm also a program manager in the SQL Server team. So I worked on the R services for SQL Server 2016. Can you actually hide the thing? Control panel. Click the orange.
Okay.
Yeah, so what do we have for agenda today is just define what is R services, just one slide on what it is. Then we'll do a quick intro on R, what are some of the things you can do in R. And then we'll look at some of the challenges for the open source R in general and how SQL Server R services addresses those challenges. We'll have other demos also on R services itself, like how to use it from SQL Server and some example scripts. Okay, so the next one, please. So yeah, so SQL Server R services. So this is basically a new feature in 2016. So we released it in CDP 3. So this is actually adding a new workload in SQL Server, which is focused on primarily advanced analytics, right? So this provides the ability to actually use the R language from within the database and use it for your advanced analytics. So the key scenarios for R and SQL together is really how to build like intelligence and predictions into our applications. So we started this journey back in 2015 after acquisition of a company called Revolution Analytics, and that is the kind of technology, and we've integrated with SQL Server. And over the course of many talks, you'll see like how we integrated that with the SQL Server query processing or SQL Server memory management and so on to make it a really good enterprise solution. So with that intro, I'll hand it over to Nellie. She'll talk about like what is R and just demo on what some of the things you can do with R. So this is just to give you guys an idea of how people interact with R today and how it will work later with SQL Server. Yeah, Nellie.
Thank you. So I'm not sure if most of you probably heard about R, but we're still going to give an introduction to R for those who haven't heard about it. So what is R? Well, R is a very popular programming language and software environment for statistical programming and machine learning. So basically used for advanced analytics. And in fact, R is actually the fastest growing language in terms of popularity today. And the reason for that is probably because R can be widely used for data mining and analytics, It is an open source language, so it has a huge community contributing to R with packages and solutions, and it's quite easy to explore data in R and try to get insights on your data, since it's a very rich language in terms of having several libraries and thousands of packages that can be used. And you can actually also create, pretty easily create data visualizations to be able to better analyze your data. And as you can see here, this basically shows that the number of packages, R packages in the CRAN library is increasing rapidly. And this is, I would say, a consequence of so many users adopting R and seeing the greatness in R. And this is just to illustrate some packages that you can use. So let's take a look. Let's take a closer look at R, and I will show you a simple example here of an R script, and we'll just walk through this together. So you can use different tools to write your R scripts and do your programming. And one very common tool is actually using RStudio. It's widely used, and Microsoft also offers R tools for Visual Studio in Visual Studio 2015. So that's what I'm using here. So I have Visual Studio here, and I just created an R project basically, and I have my R script here. The good thing about R is that if you just want to explore and try things out, there are actually a bunch of built-in data sets that you can use. The iris data set for flowers is the most known. But here, in this example, we're going to look at use a data set called state. And in the state data set, there's a subset that we can actually easily, with help functions, look at just to see the documentation of it. And if you look here for state X77, it's actually US population data for certain states from the 70s. So it's like population data, rates of illiteracy, life expectancy, murder rates, income, etc. And as I said, you don't need to write a lot of code to be able to view your data, analyze your data. Here I'm looking at the first a subset of this data just for some states, so you can get a picture of, okay, Alabama population, income, and so forth. And this is just a summary of the data. So what we're going to do now in this example is basically, I would say, a pretty typical scenario, but very simplified. We're going to do a prediction here using linear regression, a linear regression algorithm, and we're going to predict the life expectancy. So what we'll do first is that we can look at how the different parameters in this data, how they correlate to each other, and we can actually easily plot, just with one line basically, a scatter diagram showing the correlation of these different attributes in this data in pairs. And this is kind of, as you can see here, this is just one example of the different graphs that you can just easily plot just to get a view. And I can't really see here, so let's just select the 4 parameters here and take a look at this. So for example, we can see that the correlation between illiteracy and life expectancy we can see in this square here, and we can see that as the rate of illiteracy increases, the life expectancy seems to be lower. So that's just one example of like this correlation that we can just quickly see here. So prediction then. So we're going to predict the life expectancy in a hypothetical state. And to do that, to be able to do that, we first have to create a model, and we have to train that model. So what we're going to do here is that we are going to create a model and train that model based on this data set, this built-in data set. And it's a linear regression algorithm, and it's going to use population, murder rate, high school graduation rate, and frost data, which was basically number of days below freezing point, and to predict the life expectancy here. So let's create this model.
By the way, Nellie, I noticed you're running in Visual Studio. To let the audience know, Visual Studio Community is free, and Nellie's using our tools for Visual Studio.
Correct. It's absolutely free. You can just download it and start using it. And if you're familiar with Visual Studio, I would say it's a great option. Let's use that same model that we've trained and do a prediction and say, okay, what is the life expectancy in this state, hypothetical state, with a population of 300, murder rate of 10.5, the high school, these parameters give us the expected life expectancy using this model. And here we can see that the prediction says that 71 years would be life expectancy. Just a simple example to show a typical scenario where maybe a data scientist explores and finds the right algorithm to use, in this case maybe linear regression, and finds a good data set to train the model, and then to use that model to score and predict using new data. And here, if we jump over, this is just something to show you guys one way to be able to connect to, for example, SQL Server and pull your data to do computation on your client. There are a bunch of packages. We're going to, in this case, we have an example of using RODBC and the RODBC library. So what I'm going to do here is that I'm going to install that library, and I'm going to connect to the SQL Server database and select from a table. This table contains iris data. Iris data is actually a built-in data set in R2, but we just copied it to a table. So let's run this, all of it, and see a summary of that data set. Let's see here. Okay, it's not working. Let's do it. Okay, I'm installing the package, RODBC. I'm saying that I want to use that package, and I'm creating a connection string and connecting to the database and selecting that data and putting it into a variable, the input data set, and I'm going to give you a summary of what we got from the database, which is, the different sepal lengths and widths and petal lengths that are contained in that data set. So let's go back here to the slide deck. And so R is great, and you can do a lot of things with R, but then, there are some challenges with embracing R in an enterprise when you want to, operationalize it. And a very common scenario today is that, or challenge with using R in an enterprise, is that you actually move your data from its data source and out from, for example, a database to another machine where you're doing your computations. And moving data like this, especially when you have large volumes of data, is time-consuming. And it also carries security risks. So that's one of the challenges, one of the key challenges that we see. Another challenge is, as I mentioned, operationalizing your R scripts, which means that if you want to use your R scripts in production, how do you do that? Sometimes, and this is actually a very common scenario in enterprises, is that a data scientist maybe explores and creates an R script that gives, the accurate results that they think they think that you should use, and then what happens is that they have to recode that R script into another language to be able to use that in production. And this is also a very, very time-consuming process it's in today's world when enterprises really need to act fast and be flexible. This isn't a great way to work, where it could take months to actually translate that R script into something else in another language, maybe C# or whatever, and try to get the same accuracy in a language that's maybe not built for statistical analysis. So that's another challenge. And then last but not least, if you're looking for scale and performance, R has its limitation. R is single-threaded. It accommodates data sets that only fit into the memory, which is a big limitation. So these are the main big challenges in enterprises today with being able to use R, open source R. And I'm going to hand over to UC now, and he's going to talk about how SQL Server R services helps with these challenges.
Okay, sounds great. As we're switching over, I'm going to launch a poll, and this gives you a chance to give us an indication of how much you know about R. And I'll also mention that we have had a couple of questions already, which I've been able to answer. We also want to hear your questions in the chat box, especially for use cases. I know UC and Nelly are often wanting to know how you plan or want to use R, and scenarios but whatever you want to ask, whatever you want to ask.
And
So
Mark, can you make me a presenter so I can?
Yes, and I'll make you a presenter right now.
Sure,
okay, so we have a few seconds for people to go. 70% of people voted, 71, so you're going to get a chance, and then I'm going to switch the screen. You're not going to be able to vote. So let me go to the attendees here. Do you see? And I'm going to make you a presenter. And then I'll also give you the results of the poll. Let's see. All right. Do you have that? We got some feedback. Okay, wait, I have to close the poll.
Yeah.
Uh-oh. Sorry, I can't mute that. Yeah, you'll have to mute that. Well, while he's figuring out the microphone, I'm going to share the results of the poll. So we have 8% now have not heard anything about R yet, and we have 16% of our audience today. We had 80% response rate here out of 106 people on this poll. So we can see what people are using for. So let me go back to UC. Hopefully you'll be ready.
Yeah, can you hear me fine now? Yeah, I think.
Excellent.
Let me do the show screen. You're able to see the screen, right? Okay.
Right. And Nelly, I'm going to be sending you some of these questions.
Thank you.
And where do we see the questions in the panel? Like.
I'm sending them to Nelly as I see them on my panel. I'm sending them to her.
Oh, okay, great.
Because you're presenting right now, but I can send them to you.
Excellent.
All right.
Okay. So yeah, so now let's look at how some of the challenges are addressed with the SQL Server R services, right? So the first thing we talked about was the data movement, right? So this is actually a big part of how people use R today. I mean, either folks need to do it on a desktop or some analytics server. They need to set up some ETL process. Sometimes they get data from different data sources. Like your data warehouse could be in SQL Server. You could be reading data from some files. You may even be getting data from some, I don't know, Twitter feeds and things like that, right? So now all of that complexity, basically you can kind of reduce or eliminate by using a lot of the SQL Server capabilities, right? And for R specifically, that means the data doesn't go out of the server, right? So this provides security also for the data itself. And then the second part is like, how do you use R itself directly in your application? This is one of the things many customers struggle with, right? Like, so we worked with quite a few customers in the TAP program, and often what they do is they basically recode the model and the R script logic in whatever application they are using. Like it could be their Java application, it could be their C# middle tier, whatever, right? And one of the main reasons is R is GPL software, right? So that means there are only certain ways you can use it, and if you embed like the runtime in your application, for example, that means you have to essentially open source your IP, right? So those are challenges with R, and now basically we have a T-SQL interface to just invoke R, right? So that actually simplifies a lot of the access to the analytics which you built in R, because to any consumer of your SQL Server database, you can actually expose this interface, and basically, I mean, they don't even know that it's coming from R, right? And then the last thing is very important, because R, pretty much all of the packages in R, they really assume many things, like, for example, the data is resident in memory, right? And they don't really have a concept of spooling to disk or working with data which doesn't fit in memory, which is very common for SQL Server, right? And then a lot of the parallel execution capabilities are not there. There are certain packages now like do parallel and so on in R today, but it's still not an inherent feature or mechanism in R, right? So here we basically bring in all of the SQL Server capabilities, like being able to do query over in-memory data, to be able to use parallel queries and column store indexes and so on. So we basically now integrate the RevoScaler, which is one of the main acquisitions we did from the Revolution Analytics. So you can now integrate that into SQL Server. So with that, let me go to the next slide. Okay, so here this slide kind of captures at a high level what is the scenarios, right? So one of the things when we talk about like R in general is this concept of exploration and modeling, right? This is something your data scientists would typically do from their workstation, and they interact with data in the database, and they do send some queries, get the data, visualize the results, build model. So now one of the things you can do with the R services is you are now able to set what is called a compute context. So this can be SQL Server, this can be your Hadoop cluster, it can be Teradata. So there are few of these data sources, right? So now what this means is instead of getting data to the place where you want to do the compute, we can actually push the compute over to SQL Server. So this basically is a concept of function shipping, so that way you eliminate the cost of moving data to a different machine and basically get more performance. But from a data scientist perspective, we still preserve whatever behavior or semantics they expect, right? So in this example, the main function of interest for the data scientist is this RX lin mod, right? It's a linear regression function. So it basically builds a model using linear regression, and so now they can run that function on SQL Server. It's transparent to them, and they simply get a model object back. So this is one of the capabilities that our services provides, right? I'll show some examples later, and in future talks we'll get into details of this, right? So here the main pieces are like there is a SQL Server with our services enabled on the server, and then on your data scientist workstation, they can be in their R IDE. It could be R Studio. It can be your R tools for Visual Studio. It could be your R GUI, R server, anything, right? And then you need the Microsoft R client. Again, this is a free version of the client which we provide. So using that, you can actually do this SQL compute context. Then the next scenario is really how do you operationalize the R code? And this is basically to provide any application connecting to SQL Server to leverage any of the intelligence exposed using your R scripts, right? So here in 2016, all we did was we added a system stored procedure which can basically execute R script along with some piece of T-SQL code, right? And it can do whatever R can do, and you get results back, and the application just consumes it in whatever manner, right? The results can be data set, it can be images. I'll show you some examples of those. It can be any object which SQL Server can understand. So with that, we'll take a quick look at the stored procedure, right? Just the key components of the stored proc. So again, what we built here is really an extensibility mechanism, right? Currently, we have only support for R language, but in future, we'll extend it to other languages like Python, for example, right? So this procedure is essentially like a mechanism to invoke any runtime, right? So one of the parameters would be what is the runtime you're trying to use, right? So that's the language. And then the second parameter is just the script itself, right? Currently it's embedded as a literal. I mean, you can actually store it in a table and retrieve the script from there. That will also work. And then the next parameter is basically the data which needs to be sent from SQL Server, right? So this is provided in the form of a query. So it's like a select statement. I mean, the select statement again can access any data in SQL Server. If you have say poly-based integration, for example, this could even pull data from your Hadoop. It can pull data from some link server. It can access any view or object. It doesn't matter. So that's really the data part. Again, if you're familiar with T-SQL today, like there is SP execute SQL, right? For executing dynamic SQL statements, this is similar to that, except you have R script in the middle. And then you can declare a bunch of parameters which you can pass to R, and then similarly you can get back results from R. So that's at a high level what the stored proc can do, right? And the parameter bindings, I mean, it works just by name. So like in this example, you can see that there is a parameter called dim1 in T-SQL, and that gets translated to a variable called dim1 in R, right? So that's how the name binding essentially works. The other names like this input data set and output data set are predefined names for your input and output data. But that can be again changed. There are other parameters to change that. It's not shown here. So this is at a very high level how this works, right? And this script actually takes a table from SQL Server, and then it single column, and then it does like a matrix, multiplication essentially. And then lastly, yeah, you can, whatever results that you're getting from R, you can change the, names of the columns or, types and so on. This is a standard result sets class which is available in SQL Server today. What happened? It's not going to the next slide. Okay, and then lastly, whatever messages you get from R, like when you run a script from your R console and you put like print statement, for example, those are all returned to the T-SQL, the driver or the client as just regular messages on errors. So those will be shown in, like, if you're running from SSMS, you will just see it in your messages window. If R script throws an error, you'll get an error message, like a T-SQL error message. So that's how this works.
Hey, you see, we have a quick question on that slide. Someone asked,
Sure.
what is at input data 1?
Oh, yeah. So, so in the current release, we have support for only sending one data from SQL, from the T-SQL to the R script, right? So typically, if you look at an R script, it might take data from multiple tables. And in many cases, it could be unrelated tables, right? Like, for example, one could be like your transactions, say your credit card transactions or something. And then the other one could be like some demographic information of the customer or something. So you may not really want to join this because it will actually explode the data set, right? So typically the R script would consume it as two different result sets and then do something with it, right? But currently in our integration, we support only one result set which can be, pushed from SQL Server. In the future, we plan to extend it. That's why we named it like that. But this still doesn't mean that the R script cannot use multiple results. It can. It just needs to use like ODBC from within the R script. I'll show an example of how that works. And that's the way you would get like these multiple results. Okay. With that, let me do a demo.
And you see, after your demo, we have 4 questions in queue.
Yeah, sure, yeah. If it's related to this proc or something, I can answer it now.
They're just some general questions about
Oh, okay.
roadmap and technology.
Oh, yeah, okay. Excellent. Okay, so then we can keep it at the end. Okay. Okay, so here I have a stored procedure which is actually going to, build a model, right? So model in R is just an object, right? It's typically like a list object in R, and it has many, fields, and each one could be an integer, string, array, whatever, right? And the model actually encapsulates the logic needed to do the prediction, right? So in this example, what we have is a data set which basically it's a New York taxi data set. So this is one of the common machine learning data sets which folks use. So the scenario is we try to predict basically whether somebody is going to tip a particular ride or not, right? And that prediction is done based on these attributes. So in this example, it's basically how many passengers were there in the taxi, what is the distance of the trip, total distance, how long it took in seconds, and then the direct distance from point A to B, right, which can be different than like, for example, that could be like, I don't know, one-way streets or something, right? And given New York, I mean, you may have to take a very circuitous route or something, right? So now, based on the attributes on the right side, you try to predict if somebody tipped or not. So this is in R, typically this expression is called a formula, right? So that's really what it is. And then to which you pass some data, and here we are going to use this function called rx logit. So this is it stands for logistic regression. So this is again a regression model. The difference between linear regression and logistic regression is this is more like a multiple iterations model. So this is used in some scenarios where you actually want to do a better fitting, curve fitting, so to speak. And this function is actually part of the R services, and so that's really what this piece of code does, right? So it builds a model, and then one of the things we'll do is we will actually use the system time in R function to basically find out like how long it takes to build a model, right? And then at the end, what we do is we call this function called serialize in R, which basically returns a binary stream, and then we can return it to SQL Server. So the stored procedure itself is very straightforward. Like we talked about, there is a language, script parameter, and then the data, which comes in the form of a query. And here I say, hey, I want to use this name called feature data source for my data, right? And that's what you do here. So I give a specific name, and the same name is used in the R script, right? And then I declare parameters. Again, one is the model itself, which I want to get from R. The other one is how long it took to build the model, right? So as you can see, both are declared as output parameters. And the rest of this is fairly straight SQL code. I mean, you take the model and then you put it in a table, right? So let's quickly run this. So the query is actually this query. So I can run the query. It's basically I take some sample from the table and it returns some data, and then the column is what R will try to actually predict. Right. But the script is not going to return any results, but it's just going to store the model into the table, right? So now here you can see some bunch of output which came from the R script itself, and on the top, I thought I printed the message, but yeah. Yeah, so this is basically the training part, an example of, and then now you can do the reverse, right? So you've trained the model, you stored it in SQL Server, and now imagine you have your application which actually wants to do these predictions. Now it will call some stored procedure like this, and the first thing the stored proc will do is take the model stored in the database, unserialize it, and then we have this function called rxpredict. So this again takes the model and then the new data, right, which is given here, and then it tries to return a result. So let's run this.
Quick question, is there a way to have the report of how much memory a model is taking?
How much memory it's taking in R itself?
Correct. Yeah, how do people know how much memory the modeling is taking, or is it possible?
Yeah. So I mean, actually, there are a couple of ways. One is you can use within R itself this tool or mechanism called rprof, right? So that does like memory profiling, and it can do that. The other mechanism is within SQL Server. We have a DMV, like DM. I mean, we'll look into this later in detail, but like for example, we create like a resource pool for all these R processes, and that's how SQL Server actually governs the resources for R. So that DMV actually exposes some metrics, like for example, the peak memory used by the R scripts, how much writes they did, how much read, and then the CPU usage, right? So that's one of the ways you can actually get some very high level information. And then Windows has some job object performance counters, which can be used to get more insights. I'll get into those details later, like because that itself will take like probably like one session.
That's great.
There are many ways to get the memory, yeah. So here this is just a quick example of basically how you can do predictions. And the predictions in this case, I just stored it into a table. So, I mean, it's just one column, but just, yeah. It's basically a probability, and the way it usually works with R for a lot of this logistic regression model is you set a threshold and say, if the probability is like something like, I don't know, 80 to 90, 80% or greater or something, then you consider that prediction to be true, right? That's how you would. So you would probably filter this by saying something like tipped greater than 8, right? And that will tell you, okay, so this many trips were predicted to be, true for based on this model. Right? So that's this is a very quick example, and with that I'll actually show another one where you can actually. So one of the things R can do is the visualization, right? So you can generate very good visualizations, which you've seen in like many, magazines and articles and stuff. So now you can actually do that from within T-SQL too, right? So this is a very simple example. This iris data set is about like flowers and species. So it just plots like the data of the flowers. And this is just a way to show like, okay, how you can return R visuals to some application, right? In this case, it was a report builder application, a report. So imagine you can now publish this report on your Power BI dashboard and have it periodically get the data from SQL and show it, right? I'll actually show the code here. Yeah. So this is actually the piece of code which generates the report. So here we actually use this library called ggplot2. It's a very popular, I think it's like the #1 package in terms of downloads and usage in the R community. So we basically create a file and then use this function called qplot. It then prints the image to the file. You can say if it's a JPEG or PNG, GIF, whatever format, right? Similarly, you can generate like PDFs, for example, and using R functions. And then at the end, what we do is we basically read the file as a binary, data. That's what this function does, and return it to basically T-SQL, and that's it. So if you run this from the T-SQL, you're just going to get like one result set, which is just a image, and that you can now consume in any application, right, which can show the image. And then the last example I'll show is, I won't get into the details, but this is actually so TPC actually released a new benchmark called Big Bench. This is a big benchmark which is focused on both SQL and machine learning, queries, like an application which can actually use both, right? So we've been developing a solution based on SQL Server 2016, and in this example, basically the scenario is given some demographics of some customers, and so this database contains data about some websites, right? So it's like products and recommendations and so on. Think like Amazon kind of website. And this example, we are trying to predict based on demographics and click activity of the users if they are going to purchase like a particular book or they're going to look at the books in the website. So as you can see, now you can have like a very complex query in SQL Server, right? This can do a whole bunch of joins. It can do some aggregates in SQL Server, and you can then go and build a model in R, right? Here you see the same RX logic, and then you can store the model in SQL Server, and same way do the prediction, right? This is the same example as the New York taxi, but much more at a different scale, right? Similarly, the other example I will show you. So this is another query in that benchmark, which is basically to figure out groups of customers based on how often they return products, how many orders they placed, and so on, right? So this is like a classification problem. So here also you can run a very complex query, like so this query in SQL. Should run this. I won't run this. So here basically it looks at two tables in SQL Server. It uses column store. So it returns a bunch of data. Like this is on a 1 gig scale factor. So it returns about 40,000 rows, right? And now we can use this data to basically classify customers, right? Here we use a different algorithm called the k-means algorithm, right? It's a k-means clustering algorithm. So it identifies groups of customers, and then we can store it in a table, right? Like if I run this. So at the end of the script, it's going to basically insert into the table, and then you can now go analyze, how many customers are there in each cluster, right? And then you can actually go and find. Actually, this is not a good example. So imagine now you have your website and you found some clusters of customers who are actually which has actually a lot of customers. Then you may want to do some recommendations tailored towards that cluster, right? Now, on the other hand, there might be some clusters which have only very few customers in that population. So then you do a different kind of analysis for them. So this is just an example of how you would use R. With that, let me go back here.
You see, we have a few questions about people wanting the scripts or the presentation. What are you planning to share?
Oh yeah. So I think other than the benchmark, because that one we don't have like a benchmark kit developed yet, but all of the other scripts I will share. It's actually in GitHub too, but it hasn't been published yet. But I'll share the scripts.
Okay, so we'll do it. We'll talk about it out after the presentation on maybe sharing it publicly or for GitHub or some other method.
Oh yeah, definitely, yeah. I mean, it's a small zip file. I mean, I can send it and share it if you have a way to post it also. Yeah. Okay, and with that, the last few slides. So yeah, here, I mean, just to show you like where you can install. I mean, you basically, if you run setup, there is a feature under the database engine called R services, and that's what you would use to install it. There is another thing called R server in the standalone features. We'll talk about it in the future, but yeah, so that's the piece you would install. If you are using Azure VM, it's not installed by default. That's something you need to run setup again and run. And just to show like the life cycle of how this works, I mean, so you would provision your SQL Server, and I'll send links also, like where you can find the tutorials and decks for a lot of these configuration and testing purposes, right?
Right. We'll make those links available on the mailing list, so you will get it on your email.
Yeah. Okay. Sounds good. Yeah, and then the model process, we kind of looked at it like this is where you train your model, look at data, visualize results and so on. So here you can use any R client. You can use what is called compute context, which is basically pushing R execution from your R environment to SQL Server. And then you can actually train and save the model in SQL Server. And the last one we looked at, like how do you put this in a proc so that it can actually be used in your report or your Java application, whatever, right? And then the last one is like how do you tune and configure this? That in itself is like a area which we'll cover in detail separately. Yeah, here are some of the topics we're thinking about. I think one of the things we can do in the future is like just do one on installation and configuration. I built some reports also which we'll share with you. I mean, it's in GitHub today. Then we look at architecture, like how does this thing work on the database machine? What are some of the things SQL Server does to protect the SQL Server process itself, right? How can you do resource governance from within SQL Server? Like meaning like manage memory, CPU used by R, and so on. And then the whole performance and troubleshooting, like how do you find out how much memory is being consumed by R? How do you figure out how much CPU is being taken, and so on. And then like we have other scenarios and samples we can share. Yep, I think that's it.
That's
So
great. So we do have, you see a couple of questions that'll be showing in your box. And
sure.
while I'll give you a chance to maybe look at some of them. If you're going to cover some of them in future sessions, there's no need to cover them in depth for right now. You could just maybe point people to resources. But any of those you could address. And while you're talking, I am also showing the results of the earlier poll we took earlier today.
How do I, okay.
So just go ahead and read the question that you want to answer, and then...
oh yeah, sure,
yeah.
Mm-hmm. We can answer this.
Just
what is
answer
the performance?
Go ahead.
Yeah, so first question, yeah, what is the performance difference between reverse scalar utilized in database compared to utilizing reverse scalar with an XDF file? Yeah, so I mean it depends on the scenario. On the SQL, we've found that the SQL Server solution can actually scale to more cores. Like we've run on a machine with like 144 cores, and you can run with 40 cores, 60 cores, and so on. The XDF file has some limitations today. But if the data is in SQL Server, you should just do SQL compute context with the reverse scalar package, right? Can you use data in SSAS? If not, are there plans to expand the functionality in SSAS tabular? So our script itself, we are looking at how to provide access to OLAP data from within your R scripts. This is something we are looking at. SSAS, I mean, providing something similar to this, I'm not sure of the roadmap yet. We haven't discussed that one. Do you guys also work on R integration in .NET? Is it .NET? Yeah, I'm not sure what the question means though.
Yeah, so that's so Holger, you might want to ask a follow-up question if you can elaborate what you mean by that integration in .NET. What I will say is Microsoft is not rewriting R in .NET. I can definitely say that.
No, yeah. R is, this is an open source GPL thing, so it's basically, you cannot do that actually. What about SSAS, MDX, DAX? I can do it from Power BI. Is there a way to do it from Management Studio or Visual Studio? SSMS can connect to SSAS today in Object Explorer, so you can actually write your MDX queries there, just like your T-SQL editor. I think that's the authoring part. The next, can the input data set be returned using MDX? Sure, SQL Server can talk to OLAP cubes through link server, right? So that can be an input to the R script. Is there a way to have it report how much? Yeah, that we covered. Yeah, we have DMVs and those things. I hear SQL is being made available. What is the impact on the interactions between I mean, there is no impact in the sense like so currently the architecture is set up in such a way that the R actually runs outside of SQL, right? It's just a R runtime, we just invoke that. And with Linux also it will behave the same, and we don't know the timeline yet if it will be available next year, but that's something we are looking at, how to make the same features. Just to keep in mind, like SQL on Linux may not have full parity with the Windows version of SQL Server. So we don't know yet how it's going to look. Okay, yeah, I think those are all the questions we have.
Thanks very much. So we certainly appreciate UC and Nellie for your coming today, and we look forward to your future presentations. We will be letting everyone know as far as follow-up about places to find the presentation and scripts. We'll talk about that offline and then make it available to the entire mailing list. Also, if you have any feedback, since UC and Nellie are coming back, if there's any specific questions you have, just make sure you send it to us in the email, and we will make sure that we will address it. We're specifically always interested in use cases, so if you have any desire to architect something and you have already an idea of data volume or what you're trying to accomplish, we'd certainly love to discuss that with you. So we already have some feedback. Andre, thank you. It was a good presentation, so thank you, UC and Nellie. And we look forward to our next scheduled session. We'll let you know when that will be through the mailing list. Thanks everyone for attending today.
Thank you.